Hi guys, welcome back. In my last video, I got a lot of reviews from some of you guys. Some of guys mentioned that the screenshots are not clear. Just try to make them somewhat clear. So from this video onwards, I'm skipping to explain the things in screenshots. Now I will try to write everything in my notes. I'm just attaching some screenshot for my purpose, but I will write everything on the notes itself. I will read out some things. If I read out something and if I don't write them on the paper, that means those are not that important for your exam. Just considering these things. Uh, from this video, we are going to start our new unit, curve tracing and multiple integrals. Before starting off curve tracing, we have to study about some basic information, basic things like asymptotes. What is meant by asymptote? What is meant by asymptote? That's what we have to learn first. Then we will start off with how to find asymptotes and what are the different types of asymptotes. A asymptote of a curve is a straight line at a finite distance from the origin, to which the tangent of the curve tends to be a point of contact, recedes to infinity. That means we have a curve, let's suppose it is a coordinate axis. We have some random curve, like just consider a parabola. We have parabola like this. Uh, Actually, parabola shape will be like this up to certain extent. After certain extent, the uh, length of upper length of the parabola will become straight, and the tangent to this curve at infinity is known as asymptote. The tangent to the curve at infinity is known as asymptote. That means this curve will touch a line. This curve will touch a line, uh, a straight line at infinity. It's not going to touch anywhere in between. Those type of lines are known as asymptotes. How many types of asymptotes we have? We have three types of asymptotes. Three types. One is parallel to x-axis. Second one is parallel to y-axis. Third one is oblique as asymptote. Yeah, these are three types of asymptotes we have. I'm not speaking about only Cartesian curves asymptotes. I will speak about polar curves asymptotes later. It's just an extension of this. That's it. We have to transfer uh, what we call polar curves into Cartesian coordinates by using x equal to r cos theta and y is equal to r sin theta. Then whole procedure will be same. You no need to worry about uh, no need to worry about polar curves coordinates. I mean, no need to worry about polar coordinates asymptotes. Hmm. How to means first of all how knowing before knowing how to find an asymptote, just think of which type of curves will have asymptotes. Yeah, it's my question. Which type of curves will have asymptotes? Yeah, just think about this question. Simple answer is if you have a function f of x comma y, then the function must be a naught x power n plus a1y plus b1 into x power n minus 1 plus a2y square plus b2y plus c2 into x power n minus 2 plus and so on up to x power n minus n equal to 0. Something into x power n into n minus 1, n minus n equal to 0. If a curve has to check whether the curve has an asymptotes or not, the curve must be of this form. Then only it's going to have asymptotes. If it's not going to be in this form, then we can say that it's not going to have it's not going to have to check whether the given function has asymptotes or not. The given function must be of this form. That means it must and should have an x power with y coefficient. X power with y coefficient. Uh, if you consider in another way, y power with x coefficient. Y power with x coefficient. We must and should have what we call a function of degree n, in which multiplication of x power and y power must and should return must and should return uh, degree of function. These type of curve only will have asymptotes. Other type of functions I think other type of functions will not have any. I think other type of functions can't have any asymptotes. Now, now how to how to find asymptotes? Yeah, we discussed that we have three types of asymptotes. First one is parallel to x-axis. Parallel to x-axis in the sense it's a line y is equal to some constant, y is equal to k. To find this type of asymptotes, we will consider the highest power of n, x highest power of n, and its coefficients. We will equate the highest power of x n coefficient to 0. We might have some like y a1y plus b2y square plus a3y cube, something so on. We will equate it to 0. Then we will get value of y. Those values of y are the asymptotes of a given curve which are parallel to x-axis. Second type of asymptote parallel to y-axis. Same like to find an asymptote parallel to x-axis, we consider highest power of x and we equated it coefficient to 0. Same like that, we will take the highest power of y power n, and we will take its coefficient, and we equate this coefficient to 0. Something it might be a1 x plus a2 x square plus a3 x cube plus and so on equal to 0. Then we will, by solving this equation, we will get values of x. Those values of x are the equation of asymptotes. X equal to some constant is the equation of asymptote. That in the sense, it will be a line parallel to y-axis. So it's going to be like, it's a line parallel to y-axis. It's going to be the asymptote. We have to find an oblique asymptote. The procedure to find these type of asymptotes are like, if function f of x comma y is given to us, let it degree by, let's degree be n, that equal to x power n minus 2 into y square plus x power n minus 3 into y cube plus uh, x square into y power n minus 2 plus x cube into y power n minus 3 plus it's going to have an terms whose what we call degree also less than this degree of whole function, just like x square into y power n minus 3 plus y square into x power n minus 3 plus and so on. We will have lots of functions equal to 0. To find oblique asymptotes, first we will take x equal to 1 and y equal to m in all the variables where multiplication of their powers written as their powers written as n. That means what we call degree of function. Then we will substitute these values. Just like this combination is going to give us the output as n. These combination also going to give us output as n. This combination also going to give us n. This is also going to give us n. But these combinations are not going to give us n. So we will substitute these values. First 1 into y square plus 1 into y cube plus 1 into y power n minus 2 plus 1 into y power n minus 3 equal to 0. Here we said that y equal to m. We will get a function of m. Let it be y n of phi n of m is equal to some, we will get in function of m. In next iteration, we will take x equal to 1 and y is equal to m in all variables, whose multiplication of powers give us n minus 1 as output. Just consider, in this function we have these values. Multiplication of these combination will give us n minus 1, which is just less than n. That means it must and should be differed by uh, degree of function by 1. Let's consider n be 3. No. I'm not going to consider any examples over here. I'm going to take supposition for it. Yeah. Now, uh, from the preceding equation, we will get, what we will get is 1 into y power n minus 3 plus y square into 1. That implies phi n minus 1 of m is equal to m power n minus 3 plus m square. We will take it. Now, to find m, we will take like phi of n minus 1 of m by phi dash of n of m. Coordinate system. Just extension of this topic is asymptotes of polar coordinates. Yeah, we will get a function f of r comma theta. We will convert it into an function of x comma y by using transformation x equal to r cos theta, y is equal to r sin theta, and we will get a function of f of x comma y, and we know the things how to find asymptotes in Cartesian coordinate system, and we will find out them, and we resubstitute the values of x and y, and we will get an what we call asymptotes in a polar coordinate system. First, we will transform the coordinate system. In transform coordinate system, we will find its asymptotes and we will retransform it to original coordinate system. That's it. Because finding asymptotes in polar coordinate system is somewhat difficult. So we will transform the Cartesian coordinate system and we will obtain the asymptotes and we will retransform to it again. That's it. Thank you. Please share and subscribe.